Okay, we're rolling. Jason, episode 3.
Yeah.
You're working on something really cool.
Yeah.
What are you working on?
Currently, I'm working as an employee on a volunteer basis in this startup in Singapore that's trying to launch rockets into space.
And what kind is it like? What kind of rockets are they trying to launch?
So basically, just small scale rockets, not on the scale of SpaceX definitely, because we don't have the budget for it. But because of the demand for nano satellites, what this means for the rocket industry is that you can actually send rockets with much less mass into space. So this means that your rocket can be made much more affordable. So your barriers to entry into the rocket industry is actually much lower now compared to previously.
Right. Wow. And what phase of the project is this company in?
So right now we are still at the development stage. So the developing a rocket is actually pretty complex because you can't just think of it from like a business standpoint alone. You need to think about it from safety perspective, legal. You have even have politics involved. So where you can launch, for example, it actually adds a lot of complexity to your whole plan. And then on top of it all, you have your engineering challenges. So meaning to say, you need to understand physics, like the behavior of the vehicle in flight. And we're not talking about like low speeds, we're also talking about supersonic speeds. So in order to send a rocket to space, we need to understand what the rocket actually encounters from low speeds to supersonic speed range. So we have to design the rocket to be able to handle conditions at this kind of altitudes.
Right. And so I'm guessing the company is in almost research in the research phase, or has there been any development started?
I only joined it recently because I just graduated from Cranfield University recently. So regarding the history of this startup is called Equatorial Space Systems.
Equatorial Space Systems.
Yeah. So previously they were dabbling in much smaller scale rockets. So just trying to get like a proof of concept working to show to investors that they have the capability to launch a rocket. But then after that, they gradually realized that they can't like just stay small. They need to have like a bigger ambition, you know. So Simon was talking about launching an actual rocket into space. So we actually had to like start getting serious and start understanding like the vehicle dynamics of sending a rocket into space. So regarding the phase that we are really in, I would say more like engineering or research phase. So right now my role in Equatorial Space Systems is to sort of develop the aerodynamics model of a rocket in order for them to understand the behavior in flight, so that we can have like a sound fundamental analysis of a rocket system before we actually build the actual rocket itself.
Right. And what's your background, like education, specialty?
So I graduated 5 years ago in a local university in mechanical engineering. And then after that I worked for a while before I actually went for my master's last year in Cranfield University. So this offer was pretty interesting because my master's was at the intersection of computer science, physics and mathematics. So recently Equatorial Space Systems had this board advisor. He had 40 years of experience developing rockets, and he said to Simon one day that, hey, like I want to help you guys build a system build the engineering team who is capable of doing systems engineering. So he brought him on board, and then one day out of the blue, he just messaged me and said "Hey Jason, do you want to come hang out for dinner?" And he was telling me about this board advisor he had. He's like, "Hey, do you want to learn about rocket dynamics? I know you had you had a background in CFD, so basically computational fluid dynamics." Yeah. So I was saying okay, maybe it's not actually relevant, but because of my background in mathematics and physics, so transitioning to understanding rocket dynamics shouldn't be too difficult. So that's how I ended up joining the team.
Right. And you met, so I'm guessing Simon is the founder of the company?
Yeah.
And you met Simon, how did you meet Simon?
Okay, so this place used to be called Tribe Theory, right? And Tribe Theory.
Yes, back in the day.
Yeah, Tribe Theory had this event in the last year. It's called Celebrating Success. So it was basically about celebrating small successes. At the event, we actually saw a bunch of space tech guys, including Simon. Simon was this guy would say "Oh, we are launching rockets into space," and that was the first time when I connected with him. Yeah.
Right.
So 2 weeks later, I introduced him to my research supervisor at NUS, National University of Singapore.
That's where you went to undergrad.
Yeah.
Right.
Yeah. So they actually had a composites manufacturing facility there. So I was thinking hey, maybe the company needs a facility like this to manufacture their components. So I just introduced my research supervisor at NUS to Simon, and that's how we stay in contact.
Right. That's great. So you met Simon here.
Yes.
And this is Celebrating Success, which is George was running these I guess events.
Yeah.
That's how you met. Wow, well, that's fantastic. Wait, so in Southeast Asia, or let's just say Singapore, is there any startups that are in space technology or attempting to build rockets?
Okay, so space technology, yes. Rockets, no. For this fundamental reason that rockets are very, very high risk ventures. So you typically not even encounter any engineers in Singapore who fathom of the idea of sending rockets into space from Singapore.
Right.
Yeah. So in order to do that, you really need a very, very crazy guy who has the ambition like Simon.
Right.
Yeah. I really admire him. He has the balls to do that. Even for for a very, very engineering minded guy like me, I couldn't even fathom of just starting a rocket startup.
Right.
It's just so high risk. Yeah. If you understand a history of SpaceX, in order for Elon Musk to actually get funded to get contracts from NASA, he had to put in his own money first.
Right.
110 million, I think it was in the period of, it's around the year of 2006 or 2007. That's when he had so many rockets that were failing. He had 3 rocket failures before he got his first successful rocket launch. So that is how risky the rocket business is.
Right. So Equatorial Space
Systems
is in Singapore. Well, I'm guessing if it's in Singapore, in Southeast Asia, it's probably the only rocket startup.
Yeah, I think you could say so. Yeah.
Right?
Yeah.
Wow, that's amazing.
Yeah.
And so you studied mechanical engineering at NUS, and then you went and worked 5 years. Were you working in mechanical engineering capacity or?
Yep, but it wasn't exactly related to high performance engineering. It was more manufacturing based, and prior to my masters, I was working in a startup, but I was also working in manufacturing. So it definitely helps that I was working in a manufacturing sector where it was focused more on composite manufacturing, so which is more related to high performance engineering, right? So related to rocket manufacturing. So there's some element of like relationship to it. But talking about math and physics, no, not even remotely close.
Right. Now this is really exciting because I didn't even know that there was a rocket startup in Singapore. What does it take to build something like this in Singapore? Do you have to sort of go to the government and say, hey, we have this idea, we have this ambition? Because I'm guessing, because of the nature of the country, it's not something you could sort of just do as a private sector
you can't just
project, right?
Yeah, you can't just rely on like private sector funding alone, because if you look at the government defense budgets, they're way bigger than like what the private sector has to offer.
Right.
And also like if you think about it from like a political standpoint, having the capability to launch rockets into outer space is actually a very, very huge bragging right for the country itself.
Right.
So naturally the tendency to gravitate towards government contracts is actually pretty significant. It's a huge incentive to like really want to like secure this kind of contracts in order to have like a sustainable rocket business.
Right.
So
what's the so the startup is in early stage research and development, and I guess it's past ideation, because it sounds like you kind of know what the first model you want to build. What's the plan for the company?
Okay, so right now Simon is in talks with I'm not really supposed to say this. He's just in talks with potential investors. Let's just put it that way. Okay, raising funding. So that's his main job scope right now. But for the engineering team, there's also a lot of work cut out for us, because so if you understood the nature of the aerospace industry, it's actually pretty entrenched in the sense that you actually have like a lot of old timers in the aerospace industry who are, they're actually sort of like attached to the 10 or 20 year contracts. So it's sort of like a iron rice bowl for them.
Right.
Yeah. So there is actually not much of an incentive for veterans in the aerospace industry to really innovate. Whereas in contrast, for us younger generations, the younger generation of engineers, we do not have experience in the aerospace industry, much less the rocket industry. So there's this huge gap of knowledge that we need to overcome before we can actually successfully send a rocket into space. So right now, like a lot of work is cut out for us. So we have to understand like the engineering fundamentals of sending a rocket into space. So vehicle dynamics, structural integrity, guidance and control, the propulsion system. And then you have systems integration, basically like all the different systems working as one, to make sure that there is none of it actually fails during flight. Because the fault tolerance for a rocket is actually pretty low compared to like other systems that you have.
So okay, I have so many questions. But in terms of the fundraising that your company is currently doing, I mean, are we allowed to, if someone's hearing this, they're interested in some potential investors, is this like, can we broadcast this or
for this? I'll say I'll advise you to interview Simon directly. So I'm just an employee. I'm not really a representative of the company right now, so I cannot say anything too much. So for anything really related to investment, like just direct to Simon.
Sure. But we could put this out and say, hey, there's a rocket startup in Singapore. They're in the fundraising process. If you're an investor listening to this, interested in some crazy young kids in Singapore trying to launch a rocket company, they're in the R&D phase and they're in the fundraising process. So if you're interested, get in touch with us. That we can say, right?
Yeah.
Okay,
thank you.
All right.
Yeah.
No, because this is, I mean, clearly a very exciting field that is a very rare thing in this part of the world, right?
Yeah.
Or any part of the world, really. So no, it's very exciting. And so, in terms of the R&D phase that you're in, is there a lot of learnings that you guys have access to from other companies who have done a lot of the heavy lifting of the R&D? Or is that sort of like very closed proprietary information that you guys don't have access to? Because I feel like there's a lot of research that's like open sourced, right? There's information in the public domain that you don't have to do the research from like ground zero, right? You can apply a lot of learnings from the past.
Yeah, you're exactly right. So like there are actually papers from NASA, they're actually in the public domain. Just downloaded some of them yesterday. So those will be used for future referencing. So yeah, like you can actually like refer to experimental data that's been developed by scientists previously in the 1950s up to like the 1980s or even the current decade. Like those might be more recent, but like you can refer to like old experiments in the past as a sort of like starting as a baseline for like doing your rocket development and analysis. Yeah, so I wouldn't say we are really starting from ground zero, but it's more like there's just like this existing gap in the knowledge base that we need to cover. So yeah.
Gotcha. So is there, do you guys have some sort of a timeline in terms of milestones you're trying to hit, or is this something that's probably more appropriate for sort of Simon to comment on?
It's really dependent on funding right now. Right. So like right now we are, a lot of us, we're just on a volunteer basis. So like so we have like a weekly meetings with like our board advisor. So he'll like have like lessons for us like on rocket fundamentals in order to understand like this dynamics of sending a rocket in space. Yeah, so like and then the rest of the time is on us to really like do the research for ourselves, research and learning, and then like try to like complete some of our own assignments, try to see like if our understanding of the subject matter is actually correct.
Right, gotcha. Yeah. No, that makes. I mean, these are like very long processes, and the cycle is like it's really R&D heavy, of course. But you know, I'd love to talk to Simon about this because I think this is super exciting.
I'm trying to bring him more regularly to DSH because like sometimes so right now we are having a co-working space at the Amoku Industrial Park. It's a little bit out of the area, so like I'm trying to get him to come to DSH and like do co-working here. So like
that'd be great. Simon, if you're listening, come by. Let's talk. Let's learn a bit more about your crazy ideas, and I'd love to to learn what you guys are doing. I think it's super exciting. But I guess just coming back to you, Jason. So you're a mechanical engineer by training, by education. You, as a profession, you worked in mechanical engineering, and now you're doing a you're voluntarily working with this rocket startup. So clearly there's interest, you have some sort of an interest in this domain. Like, what are your ambitions? What are the things that excite you about the future of, I guess, engineering in general, and like what are the things that you are looking to do?
Some good questions. I haven't really thought about those, but I would say like generally speaking, I'm more interested in high performance engineering. So like some of the topics that my thesis topic was actually for my master's was actually pretty crazy. It was in this field called high performance computing. So don't really want to get into that. The other one was for my group project. I did some research onto this field called cavitation. So cavitation is actually pretty interesting in the sense that you can actually like I was explaining to George the other day about my group project. So I didn't really explain it from like a technical point of view, but I explained it from like a real world point of view in the sense that, hey, we actually have like a real life One Punch Man in the ocean floor.
real time.
Real life One Punch Man.
One Punch Man.
Yeah.
What's
so
a One
like,
Punch Man?
Okay, so like the One Punch Man is actually an anime in like a Japanese anime.
Oh, it's an anime. That's why.
Yeah. So what I'm saying
One
is
Punch Man. Okay, it's an anime character.
Right.
Gotcha.
So
okay.
what I'm saying, we actually have a real life One Punch Man in the ocean floor. Is that one of these marine creatures is called a pistol shrimp. So it has the ability to fire a jet that is close to 60 miles per hour. So basically it uses the idea of the concept of cavitation to actually knock out its foe.
And this is a shrimp.
It's a shrimp.
So it's a shrimp called, what's the name of the shrimp?
Pistol shrimp.
There's a pistol shrimp which is can fire off 16 jet streams of water at 16 miles per hour to take out its enemy, another shrimp or another.
Using the idea of cavitation. So cavitation is basically dependent on. So cavitation is generated using a differential in pressure regions. So if you think about it, so what a jet stream does at such a high velocity does is that it creates a low pressure region, so low that you create a cavitation bubble that when it bursts, it can release a pressure differential of like up to maybe 10 bars or even more. So it has the potential to the pistol shrimp uses this concept in order to incapacitate its foe.
Right.
Yeah. So
this cavitation is this currently being used in like rocket science?
Right now, cavitation is actually a very, very niche field. It's actually pretty hard to replicate in real life conditions because it's really based on like water conditions, for example, and it's very, very expensive to do it large scale.
Right. So it's still in a very academic. I guess development.
It's actually a pretty huge. It's a very highly researched phenomenon, especially for gas turbines, or more like for underwater propellers. Yeah. Right. So because like propellers, they rotate at such high velocities that you see like cavitation appearing near its hydrofoil. So this cavitation. Because it's the ability to release a huge pressure is actually very, very damaging to the hydrofoil itself. So there has been a lot of research in this area in order to understand how we can generate better geometry or better material surfaces in order to protect hydrofoils from eroding under the effects of cavitation.
Right. So cavitation is still a very much researched topic. It's not. It doesn't have a real world commercial application, whether it's in rockets, whether it's in any sort of commercial oil and gas sort of segment.
Yeah, I'll say its research, its applications, its real applications are more in the defense category. Yeah.
In like what kind of capacities?
Submarines, ship, or even ships, like marine vessels, they have it like a very, very huge ships because they need like a large propellers.
Right.
So like they move like water at very, very high velocities. Right. So like this, generally this would be like the kind of applications that you expect to see for cavitation related phenomena.
Right, gotcha. And so you, sorry, I went around, but like you were talking about the One Punch Man. So you were telling George there's a real life One Punch Man, and it's a shrimp, which is very good at cavitation.
Incapacitating its foe, right? Using the concept of cavitation.
Right.
Yeah.
And so you're interested in that phenomena.
So I didn't really understand how cavitation could really be applied to the real phenomena until I started doing like a literature review for my own group project. That's when I started understanding.
Right.
Like from YouTube, like hey, like cavitation is actually a very, very interesting topic. It's just that because it's such a difficult topic to tackle for like a group project that spans only like 2 months.
Right.
Yeah. That like I would say like for normal students, like it's perfectly understandable why they wouldn't want to like take up like a research thesis.
Sure.
Yeah.
So in your volunteer capacity at this rocket startup, are you providing sort of research? Like what is your contribution to the company?
Okay, so basically right now I'm doing it. I'm trying to develop an aerodynamics model for them to understand the behavior of the rocket vehicle in flight, at different stages in flight, at re-entry, but that will come later because that involves like a different set of physics. So right now we're just trying to understand like how what happens when a rocket rolls in flight, for example, what kind of physical phenomena we can actually expect, and then at high velocities, like what kind of shock waves we can expect for the rocket. Is it like a weak shock wave or is it a very, very strong shock wave? So shock waves are actually a huge deal, especially at supersonic speeds, because like if you have a shock wave, you have a very, very huge difference in temperature that you can expect for certain regions. So you need to account for like for this kind of phenomena and like design it within your structure so that they won't fail at this kind of high temperatures.
Right.
Yeah.
So you're sort of researching and building these types of models as sort of concepts for various different ways you could potentially build and launch your first rocket.
Yeah.
Right.
Yeah.
And how many people are in like volunteering at this startup?
In a volunteer capacity, I would say like there's about at least 10 to 12 people.
10 to 12 people volunteers, and how many founders, employees?
So Simon is the founder, and then there's another co-founder who's also from my undergraduate batch. Yeah, so we were from the same year, and then we have this CTO. CTO, he worked in another rocket startup company previously, so he had his own IP, and he recently transferred his IP. I think it was within the last year to ESS. So that was I think you should hear it from Simon. He's
fascinating.
Like much more clear than me. So
hey Simon, come on the show. Let's talk. No, well, this is really interesting. You know, I went to University of Southern California. In Los Angeles. So I did my MBA there, and SpaceX is very close to USC.
Oh wow!
They have I think it's Hawthorne. That's where they have like I think the main sort of that's where most of the people sit who are doing the research and I also think the supply chain and all of that is there. So I had a lot of friends who were interning at SpaceX, but not on the engineering side, on the business side. So I think there was like marketing, finance, all the non-core stuff, But yeah, it was really nice to sort of see that they were recruiting at USC, and also I think they recruit a lot of engineers from USC, because USC has a huge engineering department, and because of the proximity, I think a lot of students graduate from engineering and then work at SpaceX. So it's fantastic to see. I remember like watching the first launch with the astronauts, and I was watching it with my daughter, who was at the time, this was what, 6 months ago?
I think so.
Yeah, so she was like a year and a half, and you could tell even like she's a year and a half at the time, right? She was just like, wow. Whoa. And for Halloween, so she loves astronauts, she loves rockets. I think most kids do, but she like has like affinity for it. And for Halloween, which is coming up, Anna, my wife, she's making her astronaut outfit with like a helmet and everything. So yeah, we're super excited about this.
You've got a budding engineer over there.
That would be nice. But okay, no, this is really awesome. And so essentially you're not quite sure what area you want to get into, but you're very much interested in high pressured,
high performance engineering.
That's sort of like something that like excites you.
Yeah.
Right.
Yeah. So in my undergraduate days, I actually, so my final year project was actually building a race car.
Mm-hmm.
Yeah, I can show you the video later on. Yeah. So,
right.
So yeah. So it was like this. So this was kind of like an emulation for like Formula One.
Mm-hmm.
So we built like Formula style race cars,
Yeah.
and then like we sent it to the US and compete with like about 120 teams
Right.
all over the world.
Right.
So it was a very, very pretty interesting experience.
Yeah.
Yeah.
You guys taking off?
Yeah.
See ya.
See ya.
So in Singapore, like besides this this rocket startup, any other companies that are here that you would be like very excited to go work for?
Let me think. So when it comes to stuff related to mechanical engineering, not really a lot, I would say, because like Singapore is not the reason why mechanical engineers don't really like sort of like they don't thrive here is because like there's not really much of an ecosystem to build hardware and development in this space. So you normally see more of like the software startups or the startups related to electrical engineering, that kind of stuff. But we're talking about like building cars, building rockets. Singapore is not the place for it.
Where do they? So people like you who are interested in mechanical engineering and want to thrive in like an industry, where do people go?
If you really like want to do like this kind of high performance engineering stuff, you have to go overseas.
Right.
Yeah.
So overseas would be like, is it Europe, China? Is it the US?
The Europe, the US. So if you're talking about doing space engineering, you go to ESA, European Space Agency.
Yeah.
If you want to have like your sights set higher, NASA. But then like the catch with NASA is you need to be a US citizen.
Oh, you do?
Yeah.
Oh, really?
Yeah,
I didn't know that.
NASA, SpaceX is even more tight. Like the requirements for getting employed in SpaceX is actually much more stringent as compared to.
Wow. So you have to be a U.S. citizen to have a job at.
Yeah, because it's all about the security clearance.
Sure.
So they don't want.
Yeah, makes sense.
Yeah. So. Even for Singapore, it's the same. Like if you want to like participate in like defense projects in the government organizations, you need to be a Singaporean.
So it seems like if you're interested in that industry and you want to really work for sort of the leaders in the industry, Singaporeans have a very few options, right?
Yeah. Pretty few. The options are not a lot unless you really have like say money something, and then you go to the US for
like private
college.
sector,
and then you work for like defense contractor, like not directly for like a SpaceX for example, but more like in a subcontractor category where you don't need as high of a security clearance. Or you can work in like the automotive sector, for example. So that requires not much of a security clearance, just your visa, and that's it. You're good to go.
Or you develop your own industry.
So you develop your own capability in Singapore, and then like you have like a government buy-in, and that's when.
But surely the Singaporean government surely is like working on or are interested in developing this industry
behind the scenes. I could imagine like there's definitely some incentive, especially like if you look at like the number of nations who actually have their own rocket launching capability. I think like Simon was saying just close to 10, less than 10.
So let's see, it would be
China,
US, India,
yes.
France,
yep.
Germany, I'm sure.
Yes, I think so.
North Korea.
Yeah.
Japan, I'm sure.
Australia? No.
Australia doesn't have a space agency. South Korea?
Even South Korea is kind of like a. I don't think so.
Not.
Yeah.
Who are the others?
I think
Yeah, but that's
about it.
That's like
UK, United Kingdom.
Yeah, yes, that's right.
United Kingdom. Yeah.
Russia.
Yeah. So about
so
10. So about there.
Right. So it's a wow. Actually, I never thought about it that way. There's only literally like a handful of countries that have the capabilities in the industry in this. So it's a very, very niche.
Yeah. So like one thing that Simon was telling me that was pretty interesting is that let's say if you manage to send a rocket successfully into space, you just need one successful rocket launch, you have a unicorn.
Oh sure! Oh my goodness! Yeah,
you
definitely.
have a unicorn right there.
Yeah.
So like, but of course, like, the process of getting there is very difficult. But once you get there, everybody will want to invest.
Oh yeah, absolutely. Yeah. Wow, I'm actually super excited. Actually, what's interesting about the last couple of months? I mean, because we're a startup house, right? And we see all types of startups come through here, whether they're software, e-commerce to whatnot. I mean, literally like spanning everything, right?
Yeah.
The two areas that I think are very interesting that I'm observing in Singapore. One is the cell-based and plant-based food startups. So they're trying to make alternative shrimp, alternative seafood, or alternative milk, and I think that's a huge opportunity area for like self-reliance on food security, as well as the betterment of humanity, right? Environmental safety, et cetera. And I think Singapore is like super well situated to capitalize on this because there's so much biosciences infrastructure in Singapore, right? Labs and all of that. So it's like it seems like such a perfect place of like high IP, high research, creation of new types of foods, right? That's amazing, and you don't see too many of those, but I'm starting to see like a lot of activity in that area, which is fantastic. And then this one, then like the very mechanical engineering focused rocket startup. So it's rare, right? It's rare, but it's super exciting.
Yeah, cool. Thanks.
All right. Well, hopefully we'll talk to Simon. But if anyone is listening to this and interested in rocket startups in Singapore, come talk to us, and hopefully we can help in any capacity we can
thanks for the offer.
However we can help. All right. One last question for you. What does fear mean to you? And the reason I'm asking you this is because I think to build something like this, you have to have like high levels of risk taking appetite, which is like very much related to essentially like fear, right? So like for you specifically, what does fear mean to you?
Fear is just I don't know. I'll look at it as like some form of risk threshold. Like at the most, like your rocket just crash in, it just fails in space, and I think like I'm not sure like what are the odds, but I would say like there definitely needs to be like some failure in order for us to like really like understand, but truly understand like rocket dynamics. Like when you look at SpaceX, like they needed 3 failures before they had like 1 successful launch. So the odds of us like succeeding on our first try, I'll say like it's pretty low, Like I have to be realistic about it because like, we are engineers after all. So
I remember, I think it was in an interview or maybe reading it somewhere where the odds of things succeeding was at, I think it was like below 10%. Was what they had set the odds. Hey, like the chances of this thing working is below 10%. But it's a very, very low, low probability. But still, they made it work, which is, I mean, I guess that's just that's grit and not giving up, right?
So I think for like the starting stages, like it's more a case of you don't know what you don't know, right? So like I think like some form of failures are actually kind of necessary in order for us to grow, so that we expand our region of uncertainty where we are comfortable operating within, and then and then we from there we develop a better understanding of like how to send a rocket into space, and that's where we start gradually increasing our success rate of like sending rockets. So I would say like for me, fear is just part of the equation, you know. Like it's not really fear; it's more like risk tolerance.
Right. So for you, you break down fear into a very understandable, sort of almost like a formula-driven, like, hey, it's your appetite of how much risk you want to take, and you can kind of quantify fear in that sense. That's a very engineering way of looking at it, I guess.
So I had a lesson recently with my board advisor, and so like so there was one part she was talking about this thing called Monte Carlo simulations, right? So Monte Carlo is actually a probability-based approach towards towards understanding your systems. So basically what you're really trying to do is understand how much fault tolerance do you have for your rocket before it can actually like fail in flight.
Sure.
So like there are a lot of variables that we need to account for, and like we need to run these variables inside a simulation to understand, okay, maybe this is not the ideal scenario, but can it still work in flight? And if it's within like the if
there's a margin of error,
then we are still okay with it. Yeah, so
Monte Carlo simulation is very much used in finance, right? I remember is in portfolio theory when you're trying to construct portfolios of equities and bonds, you use a Monte Carlo simulation for
probability based.
Right, exactly. Okay, well that's a very very good answer on, I guess, quantifying and describing fear from an engineering perspective, which is awesome, because I for me, like, fear is such a emotion based sort of like if you asked me that question, my answer would be very much emotions driven.
Right.
Whereas for you, it's like, oh well, let me break it down into probabilities, risk tolerance, and so that's a very nice answer.
I guess for me, like as an engineer, like I learned to take out emotion from an equation, you know, because like you can't have like any emotion. There is part of like this venture, especially like in a venture as risky as like sending a rocket into space. So imagine like for a moment that you have like a emotion that you really want to release, and like and I think that will really fuck up everything, because like you cloud your judgment in that span. In the heat of moment, and like it might lead you to like a very bad decision making. So like really like what we really want to do is like have like a really proper decision making processes. Failures are okay as long as we learn from them. Right. I would say I'll even go as far as to say failures are inevitable in order for us to progress as an engineering team.
Sure. Yeah, makes sense. All right, that was Jason from a volunteer at a rocket startup in Singapore called Equatorial Space Systems, and hopefully we'll be talking to more people from the company. All right.
Thanks.
Awesome.
Thanks
Thank
for
you.
the interview.